Okay, so together what we're going to do is investigate this first claim. And this one's really just kind of us building up our evidence. So what we want to think about eventually is, can he throw a football over those mountains? One of the things that we're going to need if we want to figure out if he could do that is to figure out how fast can he actually throw. So what we're going to look at is we're going to use this scene of him throwing that stake at Napoleon to figure out how fast how fast is he capable of throwing. So we're going to look at this first claim. So when we're thinking about this, we have a few things we can kind of build up. I did a little bit of a recon on the internet. So what we want to look at is this idea first. Okay, he is able to hit Napoleon with a Salisbury stake. So I did a little bit of looking, and I found this my new favorite website apparently, where you can look up different spots where films are filmed. So it kind of walks you through, and it shows you a lot of the different locations about where Napoleon Dynamite is filmed. So this isn't his house. That's not it. That's not it. His house is this one. So we know where he lives. We know where this scene was shot. We look at the Google Maps. It matches up pretty nicely. Unfortunately, and then yeah, you can plug it into Google Maps. You can't see a street view with this Google Maps for some reason. If you do street view, it just kind of gives you like a weird or it won't even let you do it. But that's okay. So we see that we have this house, and then one thing that you're able to do in Google Maps is actually like measure the distance of stuff. So we'll look at that in a second, but that'll come in handy a little bit later. And then the last little thing that we're going to do is we're going to assume that this is a horizontally launched projectile. So what I want to do first, before I jump in to do any experiment, I want to think about what data is available to me, what data do I actually need, how can I figure these things out. So I'm going to pop over to OneNote, and let me switch it over so you can just see that. So we really want to think about like what do we need and how can we get what we need. So we want to figure out really our main use of this claim is we're going to mainly use it to figure out what is this v naught in the x direction. So what is this initial velocity that Uncle Rico can throw with? That's going to help us determine if he can make it over those mountains. So if we're thinking about this, we know that Uncle Rico, he stands up, and if this ball is our stake, he throws it and it hits Napoleon at some distance x away. And then we know it's going to fall some sort of vertical distance, some sort of vertical height y. But what we're going to do to make our assumption a little bit easier is we're going to say that this was a horizontally launched projectile. So what I want to figure out is this v naught, and yeah, that's kind of where we're starting with. This is our starting point. So what I want to do is I'm going to start off and think about my equations that have v naught x in them. So I can think about in this direction, in the horizontal direction, I have this equation. It says x equals x naught plus v naught t plus 1/2 at squared. And then I also have this equation that says v equals v naught x plus a xt. So let's first look at our second equation and think about if this will help us in any way. So one thing that I know about horizontal projectiles, the projectiles in the horizontal direction, is that they have an acceleration of 0. There's nothing forcing them in the air. There's no force acting on them in the horizontal direction. Vertically, we have gravity pulling us down, but horizontally, there is nothing. There's nothing accelerating us. So if we look at this equation 2, we say, well, Vx equals V naught x plus 0, because this will just be 0, because the acceleration is 0. So this equation, that doesn't help us. So this equation 2 just tells us that the velocity is the velocity. So that is no good. That's not going to help us figure out how fast he's throwing. If we look at the second equation, or really our first equation, we have this x equals x naught plus v naught xt, and then we said there's no acceleration in the horizontal direction, so just plus that 0. So we can really say, oh, if we figure out this distance equals velocity x plus time, I'm just calling x naught 0, let's say it starts at 0. So really this is telling me if I want to figure out the speed that he's able to throw at, all that I need is the distance that that stake travels in the horizontal direction. I just need x, and it looks like I also need to figure out how much time it traveled for. So that's nice. This looks like, hey, we don't need to do anything with the y direction in this case. It looks like all that we're focusing on is just the horizontal direction. So that's nice. So let's jump back over to our Google Slides over here, and then shift it back. So really, we've looked at our situation and we've determined what it is we need. So we need distance and we need time. So let's think about, in this case, how could we measure it? If we were doing it in real life, we'd go out there, we'd fly to Idaho, we'd grab a meter stick, we'd hire Uncle Rico to kind of redo that, we'd have him time it, but that's not really applicable. So what we can do is we can use that Google Maps feature that I said before to figure out the distance. So what I did was I plugged this into Google Maps, I used that measure distance feature, and I figured out that the distance from the porch where they're sitting to the street is about 22.58 meters. So 22.58 meters, I don't know if this is the exact angle, but it looks pretty close. So we know the distance now. We know horizontally the stake flew 22.58 meters. And I don't know if you can see that, sorry. So 22.58 meters. And then I was looking at time. So we're thinking about time. This one, it's a little bit tricky. So what I did was I took the clip and I kind of inputted a timer on top of it so that I could figure out, like, hey, when does it leave his hand, and then when does it hit Napoleon in the face, so we can figure out that time of travel. So we got about 0.2. That will never not make me laugh. So we got about 0.248 seconds, which is really, really fast. So let's keep going with it. So the initial velocity, if we're looking for it, we said that we can use this equation. We can figure out the distance, the time, and use this equation v naught x equals distance over time. So 22.56 meters divided by 0.24 seconds is 94.083 meters per second. So before, his claim sounded a little bit outlandish, but now it's starting to look pretty good. We're looking at these numbers. I don't know why it's spaced out like that. I'm sorry, because I had it around this. His speed is oh gosh, that was a good voice crack. His speed is 94.083 meters per second, which translates to like 210 miles per hour. So he's able to throw that stake, based on the video evidence, 210.457677 miles per hour. If you're looking at that, a baseball pitcher is about able to throw 100 miles per hour, so about 44.704 meters per second. I compared it to a baseball player just because the stake is a little bit more the size of a baseball rather than a football. But this tells us a lot. This tells us that he's got a pretty powerful arm. So that's a quick little guided use of projectiles. That one's not too bad. What we're going to do next is I'll hit you with claim number 2, and then I'll let you try it out, and then I will, so that'll be in a Google form, and then, or maybe a video in a Google form. Yeah, it'll be I'll introduce it in a video, and then I'll set you free to try it, and then I'll have a video key that you can watch. That's going to be in the next one.